from the 6 sections that we're reviewing, there's 4 on each. So looking at the first one, stated the polygons are similar. One thing that we have to do, the sides have to be proportional and the angles have to be congruent. So if I check on the sides, I notice that all the sides on one are 15. So if I check two sides, they're going to be 15. If I check the corresponding sides on the other one, are going to be 10. And one way we can come and check that they are proportional, Luis, way we can check that they're proportional, one, we can cross multiply. It should be the same thing on both, or they should simplify to the same thing. Right? If you cross multiply or simplify each fraction, you realize that they are the same thing. Also, so at least my sides are proportional. Now for my angles, I notice this 80 on the top corner should copy over here, right on the corresponding spot. I know per parallelograms, two adjacent angles have to add up to 180. So that means it's okay. So I'm going to say this is similar. Remember, my angles have to be congruent, and my sides have to be proportional. So any questions on the first 4? 7? Number 2. If I look at the sides, one of them is 15 and 12. So I'm going to write, I write them from small to large, 15 and 12. I notice on the other side are 5 and 4. I wrote them from small to large. One way, once again, it's cross multiply. It should be the same thing on both. I'm going to simplify. 12 over 4 is the same thing as 3 over 1. 15 over 5 is the same thing as 3 over 1. So at least sides are proportional. Angles, I notice that they're all 90 on both figures. So the angles are equal. So similar. All right. Any other questions on the first 4? No? All right. Now looking at question number 5. These polygons in each pair are similar. Find the missing side length. So because they are similar, I know my sides are proportional. My question mark, let me call it x. So from my one triangle where x is, the two numbers I'm going to use are going to be 6 and x. Which one is smaller, 6 or x? 6. 6. So let me write my 6 first. On the other triangle, my numbers are 3 and 7. We know 3 is smaller, so let me write 3 and 7. Simplify your fractions if you wish, or cross multiply already. I think the numbers are small enough, so I'm not going to simplify. We can, but I'm not going to simplify. I'm just going to get that 3x is equal to 42, right? I cross multiply. 3x equals 42. What's x? 14. And remember, if we're simplifying, we can do the same fraction, like 6 over 3. We can simplify the fraction, or side to side, like 3 and 7 if we could. The only way we cannot simplify is diagonal. All right. Any questions up until 8? 7? All right, looking at number 7, on one triangle, I'm going to use the measurements 20 and 35. Well, I mean, one of my quadrilaterals, 20 and 35, and I like to write it from small to large. So obviously 20 first. From the other triangle, the other quadrilateral, the corresponding numbers are x and 42. We can tell x is smaller. So I'm going to write x and 42. Here I do want to simplify first. The number's a little bit too big, so let me simplify first. I can simplify top and bottom. 35 over 42. Let me divide each by 7. So we get 5 over 6. Another way we can simplify is side to side. The 5 with the 20. So I'm going to get 4 and 1. So I have 4 over x is equal to 1 over 6. I know 4 and 6 can both be divided by 2, but I cannot simplify diagonals. So like as a reminder, do not simplify diagonals. So what's x? 24. As I said, the way we multiply, I think I said this last semester, the way we multiply is the only way we cannot simplify. So we multiply diagonal, that's the only way we cannot simplify. Kind of like remember in fractions, when you guys were pre-algebra or something like this, 3 over 6 times 5 over, I don't know, 15. In that case, you multiply straight across, that's the only way we cannot simplify. Like when we multiply fractions, I'm talking about different topics. We could do top and bottom or cross, but not straight because that's how you multiply. In here, for proportions, you multiply diagonal, so that's the only way you cannot simplify. Multiplying fractions is something we're going to see later on, but obviously we're in geometry, so my fractions are not going to be that simple. They're going to be a little bit bigger numbers, and once we cover that, the hardest part, it might sound a little crazy, but the hardest part will be simplifying a fraction. Just because we have bigger numbers. All right, going back to today's topic, any questions on the first 8? No? All right, looking at question number 9, my two measurements I'm going to use from the left figure are 15 and 9. Remember, I like to write from small to large. And the reason why is because that way I keep an order and it's easier to not get lost. On the other figure, I'm going to use 12 and x. Remember the question mark, I call it x. Which one's smaller, 12 or x? 12. So we're going to go 12 and x. 9 over 12, I'm going to call that 3 over 4. Right, I simplify the fraction. Side to side, 3 and 15, let me divide each by 3. So just to make it a little more clear, I have 1 over 4 is equal to 5 over x. So what's x? 20. Oh, my bad. Number 9, we're still solving for x, but now for 9 through 12, in my x, I have either a plus or minus. That's the only difference. So looking at question number 9, the measurements I'm going to use from the left are 15 and 4x minus 7. Which one is smaller? 15. So 15 and then 4x minus 7. Remember, I list them from small to large. From the other figure, I'm going to use the numbers 12 and 20. That one we can tell which one's smaller. 15 over 12, let me divide each by 3. So I'm going to call that 5 over 4. Side to side, 4 and 20, I'm going to simplify to that to 1 and 5. When you cross multiplied this way, make sure the number that is by itself, in this case a 1, make sure you multiply it to both. Okay, it doesn't make a difference right now, but if it was not a 1, it would make a difference. So make sure you multiply it to both. So we have 4x minus 7 is equal to 25. All right, 5 times 5 gave me 25. I think the rest you guys can do. If 4x minus 7 equals 25, what's x? 8. X equals 8. All right, anything up until number 12? Number 10? Looking at number 10, the two measurements I'm going to use from the top are going to be 20 and 2x plus 17. We can tell 20 is a little bit smaller. The corresponding sides on the other figure are going to be 24 and 42. Now the corresponding sides, And we can tell that 24 is smaller than 42. 20 over 24 divided by 4. Oh, better.
No, 2. 10 and 12.
Well, let's divide by 4 instead to make it a little bit smaller.
Yeah.
So 5 over 6. If you cross multiply, make sure the 6 you multiply it to the 2 and to the 17. But I'm going to make my 6 a little bit smaller. I'm going to simplify 6 and 42. 1 and 7. So my 1, make sure you multiply to both. So I have 2x plus 17 is equal to 35. Right? Cross multiply. So you get that 2x is equal to 18. So what's x?
10.
9, yes.
Oh.
Okay. Any questions up until 12? So far, not bad. Number 13. We're going to compare. The only thing here, though, my figures could be flipped. I could be flipping my figures. So don't think that WU goes straightly to RX. I said the figures could be flipped. But I'm going to use, let's say here, on my small figure, I'm going to use the numbers 30 and 60. And I can tell 30 is smaller, so I'm going to go 30 and then 60. On my other triangle, I'm going to use the numbers 72 and x. Which one is smaller? 72. So I'm going to say 72 and x. If you cannot tell, like I said, right now we can tell which one is smaller, like it's easy to tell. If we cannot tell, use a notation. Notice how on the notation, VW is a small side, right? VW is a small side. If I look at my notation, that's the first 2 letters of one triangle. So the corresponding side are the first 2 letters of the other triangle. I said use a notation. VW is the small one, so QR is the small one as well. I said if you cannot tell, use a notation. Okay, now here, I'm going to simplify side to side first. 30 and 60. I'm going to call that 1 and 2. So what's the value of x? 144. Any questions up until 16? 14. 14? Okay. Looking at 14, the small triangle, the measurements are x and 7. Can we tell which one's smaller?
7.
7? Okay, so 7, I'm going to write it before x. On the big triangle, my measurements are 70 and 80. Keep in mind, I'm looking at the entire side of the triangle. So 70 and 80. If I simplify those, I get 7 and 8. By 70 and 80 divide each by 10, we get 7 and 8. Think the rest you guys can finish. What's the value of x? 8. All right, anything up until 16? All right, now for 17, solve for x. The triangles in each pair are similar. Well, I shall let you guys finish those. Let me take a look at number 18. Or better yet, I think 18 up until 20 is pretty similar. Any questions up until 20? So up until 20, are we good? Okay. All right, now let me take a look at 21 because we have to complete a statement. Number 21, state if the triangles in each pair are similar. If so, state how you know they are similar and complete the similarity statement. So let me see if my sides are proportional. On one triangle, my measurements are 8 and 13. So I'm going to write 8 and 13. On my other triangle, my measurements are 81 and 126. 81 and 126. If they are proportional, then the triangles might be similar. Two ways on how to check they're proportional. Cross multiply. 8 times 26 should equal 81 times 13. That's one way. Cross multiply. The other way is simplify each fraction, and it should simplify to the same thing. If I multiplied 8 times 126, if I cross multiply, I know my last number should be an 8. Right? 8 times 126, my last number is an 8. If I cross multiply the other way, 81 times 13, I know my last number should be 3. Right? So you think those two are going to be proportional? No. All right, so not similar. If you have a calculator, you can find out what those numbers are and find out that they're not proportional. If the sides were proportional, I would have said that because of vertical angle theorem, I will mark those two angles and it would be by side angle side. If they were proportional. But my sides are not, so no. All right, any questions up until 24? Which one? 22. All right. Looking at 22, let me see if my sides are proportional. I'm going to say 20 and 26 from one triangle, 30 and 39 from the other. I know the last number in each is 0, so let me simplify first. Right, 2 over 3, 26 and 39, let me divide each by 13. So I get 2 over 3. So I think they are proportional. I can mark this angle with this angle by vertical angle theorem. So remember, because the sides are proportional, I'm using the sides, I'm using the angles. Which rule is that one? Side angle side. So not on the arrow, not on the space there. I'm gonna be right after. I'm gonna write by side angle side. Have to complete this statement. DEF is similar to triangle. Notice how DE is the big side, right? I said DEF, I have to go over the big side first, so make sure you call this DVW. You have to go over the big side first. The order does matter, so we call it DWV, it's incorrect. DVW is the correct way. Like order of the letters does matter. Any other questions up until 24?
Does it matter in what place you put the top numbers? Like when you name the size 20 and 26, does it matter?
As long as you keep them both, like the two numbers that come from the same triangle, like the 20 and 26, as long as we keep both of them on the numerator or both of them on the denominator. Like your question was like, if we would have gone at the bottom instead of the top like we did, and then the other one 30 and 39, like we were to flip it, it's okay.
And if you were to flip 30 and 39, just switch them, that would be okay too. It doesn't matter. Yeah.
Like you mean the 39 here and the 30 here?
Yeah.
That does matter. Like I do keep them from small to large. So 30 before 39. Yeah, it does matter. Any other questions? You good for the quiz for tomorrow? Or as good as the other week? Do you have another question?
Yeah, on the last one we put 8 over 81, but that was the other week.
This one over here?
Yeah.
what I did was, like, if I look at these two numbers, right? They come from the same triangle. Remember, you gotta get two numbers from the same triangle and keep them either numerator or denominator, but keep both in the same place.
Okay.
So I did 8 and 13, right? Notice I went from small to large. So either both on the top or both at the bottom. Then on the other triangle, you go 81 and 126, right? From small to large. Now your question was like, what if instead of the top, I would have gone 8 and 13, but instead of the numerator, I use the denominator. Then on the other one, go 81 and 126. It will be okay. All right. Any other